Hello, my phenomenal viewers, and welcome on today's episode. On today's episode, we will be answering this GCE 2021 question 7. The question has two parts. It has the Roman 1 part, which is under polynomial, and a Roman 2 part, which is under differentiation. So the Roman 1 part reads, show that the equation f of x is equals to 0, where f of x is equals to 3x cubed minus x squared plus 3x minus 1 has a root between 0 and 1. So let us answer this Roman 1 part first before diving into answering the Roman 2 part of the question. So whenever you are given a function to show that there is a root of that function within a given interval, all you simply need to do is to show that the function changes sign within that interval. That is, either the function changes its sign from positive to negative or from negative to positive. So that is what we are going to do. So what we need to do here is to substitute 0 into f of x and note the sign of the value that we are going to have, and also substitute 1 into f of x and note the sign of the value that we are going to have. If there is a difference between the signs of these two values, then we conclude that f of x truly has a root in between this interval. But if the signs of the values are the same, then we conclude that this function does not have a root in between these two values, which are 0 and 1. So let us do that together. So we'll be given the function f of x. So Roman 1 part, f of x is equal to 3x cubed minus x squared plus 3x minus 1. So the first value is 0. So we need to determine the sign of f of 0. So f of 0 simply means we should go into this function f of x, and anywhere we see x, we replace it with 0. So I have 3 into 0 cubed minus 0 squared plus 3 into 0 minus 1. So this becomes 0, this becomes 0, this becomes 0. I'm left with negative 1. So f of 0 is equals to negative 1. So it shows that the value of f of 0 is equals to a negative value. Now let us determine the sign of f of 1. F of 1, we do the same thing. We go into the function f of x, and anywhere we see x, we replace it with 1. So I have 3 into 1 cubed minus 1 squared plus 3 into 1 minus 1. 1 cube gives me 1, then 1 times 3 gives me 3. 1 squared gives me 1, then I have the negative out, minus 1. 3 times 1 gives me 3, then I have minus 1. So I have 3 minus 1, that gives me 2, plus 3, that gives me 5, minus 1, that gives me 4. So f of 1 is positive 4. So now let us look at the signs of these two values. When you look at f of 0, you notice that the sign is negative. When you look at f of 1, you notice that the sign is positive. So since f of x has changed its sign between these two values, then it shows that there is a root of this function that lies between 0 and 1, because it shows that this function kept the x-axis in between these two values, 0 and 1. So we conclude that hence since f of 0 times f of 1 is lesser than 0, this implies there is a root. There is a root between 0 and 1. So that is how you need to answer this question. Whenever you are asked to show that a root of a function lies in between two values or within a given interval, you simply need to show that this function changes its sign within that interval. So if the Roman 1 part of the question has been understood, let us move to the Roman 2 part of this question, which is under differentiation. So the Roman 2 of this question reads, Given that the parametric equation of a curve x is equals to sine 2 theta, y is equals to cos 2 theta, find the squared y on the x squared in terms of theta. So the equation of this curve has been given to us in terms of a parameter which is what? Theta. So x is equals to sine 2 theta and y is equals to cos 2 theta. So where theta here is the parameter. Now there are two ways in which you can solve this question, but I prefer using the method that I want to use, which is when we are given the equation of a curve in terms of a parameter, then we differentiate x with respect to the parameter, you differentiate y with respect to the parameter as well. So when you do this, this implies the x all over the theta becomes, for you to differentiate this, you differentiate this angle, which is what? 2 theta. When you differentiate 2 theta, you're going to have 2. So you have 2. Then what is the derivative of sine? It is cos of the same angle. So that is how you differentiate this kind of functions. You first of all differentiate the angle given to you, which is 2 theta. You're going to have 2. Then multiply it by the derivative of the trig function that you have. In this case, it is sine, and its derivative is cos. We do the same thing with the y on the theta. When I differentiate 2 theta, I'm going to have 2. When I differentiate cos, I'm going to have negative sine of the same angle, 2 theta. So this implies the y on the theta is negative 2 sine 2 theta. Now we are going to apply the chain rule of differentiation here, which is the y on the x in this case will be equal to the y on the theta divided by the x on the theta. And this is going to give us what? What is the y on the theta? The y on the theta is negative 2 sine 2 theta divided by what is the x on the theta? The x on the theta is 2 cos 2 theta. 2 cos 2 theta. So this gives me what? Negative tan 2 theta. So this is the y on the x. But the question has asked us to determine the squared y on the x squared. Now, for you to obtain this, there is a formula that you need to know, which is the squared y on the x squared is equal to d of the y on the x with respect to theta divided by the x on the theta. So this simply means that we should differentiate the y on the x, which is what? Negative tan 2 theta. Then we multiply it with the x on the theta. And what is our the x on the theta? The x on the theta is 2 cos 2 theta. Now, when we differentiate this, so this simply means the derivative of negative tan 2 theta d theta divided by the x on the theta. The x on the theta is 2 cos 2 theta. So I have 2 cos 2 theta here. So this becomes, remember this is the squared y on the x squared, the squared y on the x squared becomes, for me to differentiate tan 2 theta, I do the same thing. When I differentiate this angle, I'm going to have 2. But remember, we have a negative there, so I have negative 2. Then when I differentiate tan, I'm going to have sec squared. So I have sec squared, the same angle. Now, divided by cos 2 theta. 2 cos 2 theta. Divided by 2 cos 2 theta. So this gives me, this cancels with this. I'm going to be left with negative. Remember, 1 all over cos 2 theta is the same as sec 2 theta. So I have sec square 2 theta times sec 2 theta. So this gives me negative sec cube 2 theta. Negative sec cube 2 theta. So therefore, our d squared y on the x squared is negative sec cube 2 theta. So this is negative sec cube 2 theta. If you like this video, please help me and share so that it can get to many students as possible. And if this is your first time to come across any of my videos, please do not hesitate to either subscribe or follow me. And thank you for watching. Stay blessed.